Alright guys, we have question 7 from the 7th chapter of Beer Johnston textbook in geomechanics, and we know that the turnbuckle has been tightened until the tension in the wire 80 is 850 newtons, and we need to determine the internal forces at point K. So previously in the channel we solved this question for point J. Now we're going to be solving it for point K, and as always we're going to start with the free body diagram. So we're going to do our section in here, and we're going to consider this part of this system, and let's just draw the free body diagram first. So we have the tension in the cable AD, so just going to call this TAD. We have two different forces at point K, so we're going to do the shear force, we're going to call it V, and the axial force we're going to call it F, and we're going to have a moment or bending moment. We know this part, so from here to here we have 100 millimeter plus 100 millimeter, or 200 millimeter. The other length in here would be 120 millimeter. And if we want to find the angle that T80 makes with our horizontal, or we should say our x component, let's just call our x and y in here. So we're going to call this our x and y. So in order to find the x and y component, we need this angle right here, call it alpha. And if we want to find that, actually it's not that hard to find that angle. We have this right triangle here where this side is 280 minus 120, which will be 160, and this one would be 300. So if we use Pythagorean theorem, we can find the 80, which will be the square root of 160 squared plus 300 squared. That's going to give us 340 millimeters. So now we have all the information. This is the angle alpha that we were talking about. So now we are good to go to do our equilibrium equations for the free body diagram of this section of this frame. So we're going to do sum of all forces in x equals 0, and this will be our positive x. So we're going to have TAD cosine of alpha, and if you look at this right triangle, cosine of alpha would be 160 over 340 minus V is equal to 0. We know our TAD is 850, so this will be equal to 850 newtons. So our V is basically 850 times 160 divided by 340. So 850 times 160 divided by 340, which is going to give us 400 newtons, no negative sign. So our assumption for the direction of V was correct. Now we have our second equation, sum of all forces in y is equal to 0. And this time we're going to have minus TAD, since it's downward, sine of alpha, which will be the opposite, 300 divided by hypotenuse, 340, minus F is equal to 0. And we can see that we're going to get a negative sign for F, which shows our assumption was not correct. 300 times TAD, which was 850 divided by 340. 300 times 850 times 340 divided by 340. That's going to be 750. And we have a negative sign that shows that our F is actually upward. So now we have to find the bending moment. So we're going to do sum of all moments about K. We're going to call counterclockwise positive as always. So we have the moment M, which we assume that it's a counterclockwise for now. So we have a positive M plus, now we're going to go with the x and y component of TAD. This will be the x component, and this will be the y component. The moment of x component, as we can see, is in this direction, so it's clockwise, so we have a negative moment, so minus the force was T80 850, the x component was what we had in here, times 160 divided by 340, that's the force, and the distance that we have is the force to the line of action, which is what we have in here, or 200 millimeter. We're going to divide by 1000 to get it in meter, and that's pretty much everything for the first moment. Let's go with the moment of y. This one's also clockwise, about point k. So another negative moment, minus 850 times the y component was this one, 300 divided by 340 times the distance, the vertical distance to the line of action, which is what we have from here to here, 120 millimeter times 120 divided by 1000 equals 0 because of the equilibrium, so we can find m in here. So our m would be 850 times 160 times 200 divided by 340, 123. So it's going to be 80 plus 850 times 300 times 120 divided by 340, 123 plus 90. So 90 plus 80 is going to give us 170 Newton meter. We did not get any negative sign that shows the moment is counterclockwise, and that would be the last moment. And some of you guys might go with the bottom part in here, and if you, instead of the top portion of this, go with the KCD instead, everything would be the same. You just have like the opposite direction for each of them. So if you decided to go with the free body diagram of KCD, so you're going to consider the bottom part. So we're going to have the same force, same moment. It just, everything will be in the opposite direction. We found the force was upward in there. This will be our F. So our V was to the left in here. So here to the right V, and the moment was counterclockwise there. Here would be clockwise. With the same magnitude for everything, it's just the opposite directions. If you decided to go with the bottom part, you're going to get the same answer for F, V, and hope everything was clear. Let me know if you guys have any questions, and you guys take care. I'll see you in the next one.